Good afternoon, everyone. So welcome to my YouTube channel, Math Saptaram. So today we are going to see second lecture on subgroups. Okay. So in this lecture we will find necessary and sufficient condition for being a subgroup or a non-empty subset of a group. Okay. So let's see that result. We are calling it a theorem. So let G be a group and H be a non-empty subset of G. Then H is a subgroup of G if and only if AB belongs to G and A inverse belongs to, AB belongs to H and A inverse belongs to H, AB belongs to H. So what is the meaning of AB belongs to H? It means H satisfies closure property. And A inverse belongs to H means H has existence of inverse for each element A belongs to H. It means if you have a non-empty subset which is closed under which has closure property as well as existence of inverse, then this is going to be subgroup of G. Okay. So first we are assuming that H is a subgroup of G, and we are taking A and B belongs to H. Since H is a subgroup of G, so this implies H is a group with respect to operation of G. So by closure, because since H is a group, AB will belongs to H by closure property in H. Okay. And A inverse will belongs to H by existence of inverse in H, because H is a group. Okay. By assumption. So we have AB belongs to H and A inverse belongs to H. Overall AB belongs to H. So we are done. Okay. Now conversely assume that. So one direction is done. Now we are going to go converse direction. Reverse direction, sorry. So conversely assume that AB belongs to H and A inverse belongs to H, for all AB belongs to H. Now we will show that H is a group. Now what is the, we will see that H satisfies closure property. So let AB belongs to H. By assumption, AB will belongs to H because we have assumed these two conditions. By that first condition, AB belongs to H. So closure property is satisfied in H. It means holds in H. Now existence of identity. Since we have A inverse belongs to H, for all A belongs to H. Now we also have AB belongs to H, for all AB belongs to H. Okay. Now we can take B is equal to A inverse because you take A belongs to H, its inverse is belonging to H. So we are calling B is equal to A inverse. So now we will put B is equal to A inverse here. Then it is A inverse belongs to H, for all A belongs to H. But A inverse is nothing but identity because H is subset of a group and A inverse is nothing but identity by existence of inverse in a group. Ultimately, we know that H is a subset of G. G is a group and A and A inverse belongs to G and A inverse is inverse of A in G. So A inverse is identity. Okay. E is the identity element in group G. So E is equal to EA, for all A belongs to G, but H is subset of G. So because H is subset of G, and for any element A belongs to G, we have this one. So H is subset of G. For all A belongs to H, it will also hold. This statement will also hold. So H is also identity element in H. Therefore, H has identity element same as that of G. Okay. जो H का आइडेंटिटी एलिमेंट होगा वो G का एलिमेंट आइडेंटिटी एलिमेंट होगा, दोनों का आइडेंटिटी एलिमेंट सेम है. Associative property. Let A, B, C belongs to H. H is subset of G. So A, B, C also belongs to G. The group associative property hold in group. So A, B, C is equal to A, B, C. So A, B, C is equal to A, B, C for all A, B belongs to H. Associative property holds in H. Okay. Now existence of inverse. Let A belongs to H. Then by assumption we have A inverse belongs to H. Now H is subset of G and A inverse belongs to G. A inverse is the inverse of A in G. We have A inverse is equal to identity is equal to A inverse. So given A belongs to H, there exists A inverse belongs to H such that A inverse is equal to E is equal to A inverse. So it means every element in H has inverse in it. Since H is so H satisfies all the conditions of group. So therefore, we conclude that H is a group. Therefore, H is a subgroup of G. Okay. So this theorem is done. Now we will use this theorem to prove that SL and R is a subgroup of GL and R. Okay. So what we will do, that we will show that SL and R is subset of GL and R, and SL and R is non-empty. So identity elements belongs to SL and R because it belongs to M and R and its determinant is 1. Okay. Identity matrix always had determinant 1. Okay. So it belongs to SL and R. So SL and R is non-empty. Okay. So, and you take A belongs to SL and R implies A belongs to M and R and its determinant is 1. 1 is non-zero. So A belongs to M and R. So determinant of A is non-zero. So A belongs to GL and R. Now, you are taking element in SL and R and that is falling in GL and R. So this implies SL and R is subset of GL and R. Okay. So we have SL and R is subset of GL and R and SL and R is non-empty. Now, next we will use that result to prove that above theorem or above result to prove that SL and R is a subgroup. So let AB belongs to SL and R. A belongs to SL and R means A belongs to M and R and determinant of 1. A is 1, that is non-zero. A belongs, so this implies A belongs to GL and R. But once you have A belongs to GL and R, it means A determinant of a non-zero. And a matrix is invertible if and only if its determinant is non-zero. So A inverse will also belong to GL and R, and determinant of A inverse is 1 upon determinant of A is equal to 1 upon 1 is equal to 1. So what does it mean? A belongs to M and R and determinant of A inverse is 1. So it means A inverse belongs to SL and R. Okay. So inverse condition is done. Now AB belongs to SL and R implies AB belongs to M and R and both the determinants of A and B is 1. So you take multiplication, AB belongs to M and R and determinant of AB is nothing but determinant of A, determinant of B. And you, what if, because A and B have determinant 1, so determinant of AB is 1. So we have that AB is equal to M and R and determinant of AB is equal to 1. So it means AB belongs to SL and R. So what we have AB belongs to SL and R and A inverse belongs to SL and R. For all AB belongs to SL and R. So SL and R is a subgroup of GL and R by above theorem. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my channel. So thank you very much for today's lecture. Thank you. We will see you in next lecture.